let's talk about the equilibrium constant known as KSP. Okay, when we're dealing with very slightly soluble solids, ionic compounds in water. Okay, for example, lead chloride, we say, if you remember from Chem 105, we say that's insoluble in water, if you remember your solubility rules. What that means is it doesn't really mean zero solubility. When we say something is insoluble, what we really mean is very slightly soluble, very low concentration dissolved. So for these types of reaction, okay, the equilibrium constant is known as the KSP, solubility product. Why? What would be the KEQ for this? It's going to be activity of lead ions times products, right? Times activity of chloride ions squared divided by, what's the activity of a solid? 1. So the KEQ for this, you can see, is just a product of activities because your denominator is 1, right? So that's why we say, we call it KSP. SP stands for solubility product. Okay, so KSP is known as a solubility product constant. That's what KSP means. Okay. So let's look at this example right here. What would be the KEQ for what would be the reaction whose KEQ is called the KSP of bismuth sulfide? So what would this reaction be? You're dealing with Bi2S3 solid. What happens to it in water? Ionic compound. What are the charges of the ions? Sulfide, what do you know is the charge of sulfide? Group 6A, column 16 of your periodic table, so that's -2. So what's the charge of bismuth here? -2 times 3 is -6, so what must bismuth be? Something times 2 must be +6. So bismuth must be +3. So this gives you 2 bismuth ions with a +3 charge plus 3 sulfide ions with a -2 charge in aqueous solution. So that's the reaction. What's the expression for KSP? KSP equals products over reactants, but reactant activity of the reactant is just 1 since it's a solid, so it's just the product of the activities of the products. So what would it be? Bismuth concentration or activity raised to the power 2 times the concentration of sulfide raised to the power 3. So that's the expression for the KSP. And this is the chemical equation for it. Okay?